So my name is Nagyfi. I am from Kicsi, Budapest, and I work in research and development. And my topic will be about artificial intelligence, more precisely about music recommendation systems using machine learning solutions and also automatic music generation using software. So I will try my best to fit into this tight 20-minute schedule. So we have long figured out how to digitize music, and in the exchange of sacrificing quality, we managed to record music in a way that it almost sounds the exact same on the same devices all the time, and it is much more easier, especially nowadays, to store it and distribute it. And due to the current advancements in technology, now we can say that online distributions and streams in the music industry has outdone the offline market. But this same goes for all kinds of other media. For instance, with movies, video streams, and also video games, online stores outdo the offline ones because consumers want to have their content as fast as possible, and most of them consume them on their smart devices. But this comes with a lot of new problems. For instance, more than 300 hours of video is being uploaded to YouTube every single minute, which causes a lot of problems. For instance, if we want to know whether or not a video is copyrighted, how can we be sure that some kind of video includes the snippet that shouldn't be there? We cannot employ like 300 people who have listened to each and every song in the world and know which one is copyrighted in which country, and ask them to listen to each and every video and figure out whether or not a 12-year-old used one of the snippets in their Minecraft video and should go to jail for this. And also another problem, especially for Spotify, they get more than 30 million songs in their library. So how are you going to figure out which 12 should they recommend to one of the users to listen to? And even more harder problem, how are you going to figure out how to recommend 12 songs, different 12 songs for each and every one of their 140 million users? And the problem is that computers do not listen to music the way we do. They do not have a concept of music like we do. We have no problems of understanding sounds, songs, speech, and so on. But computers have a different kind of mathematical representation of these songs. And all they can do is basically apply certain kinds of mathematical functions on these representations and figure out something. And then again, we cannot just simply apply meta text to these songs. So you can just label each and every one of them like this one has a male vocal in it, this one has so and so instruments in it, because of the vast number of all these contents being created. Some companies have tried, some of them even outsource it, like Discogs, where you can add your very own text, but only a really small number of their music have proper labels on it. So it's basically an impossible thing to do if you don't want to automate it. But thankfully, the engineers figured out music instruction retrieval techniques, which means that using certain kinds of functions, we are able to give estimations that would, about properties of the songs that would actually make sense to a human. So we can actually estimate the genre, the list of instruments, and so on with the song. And we can also say, tell if two songs are similar. And this way we can more or less figure out copyright infringement. But there is another problem. Think about recommendation. Just because you can say that this song has certain kinds of elements, like these two songs have the same 4 accords in it, maybe they both have the same amount of silence in the beginning and the end of the song, it doesn't mean that they're really similar. It just means that there is like 100 million other songs that are similar to this. Are you sure you're going to recommend it to someone else? So what people figured out, this slide is actually directly taken from Spotify's big data presentation, is that instead of just simply looking at the songs and trying to figure out data about the songs, we are also looking at the people who are listening to these songs. So instead of just analyzing the waveforms, we are also analyzing the digital footprints of people who are listening to music. And this way, we know much more about the music we want to get information about. This pretty much sums it up. If you have two people, one of them likes PQRS songs and the other one likes QRST, there is a similarity there. So it is plausible to say that if one recommends P to the other and the other recommends T to the other, they might like it because they have similar taste to some extent. But the problem is that we do not really explicitly give any kind of information about our taste. So we rarely go to a site and say, I give 5 stars to this song because I liked it so much. I give 1 star to this song because I don't like it, even though I listen to it all the time. But this is not really a problem in this environment. For instance, in Netflix, whenever you watch one of their videos, people rarely give ratings at the very end, but that's not a problem for them, because they're also recording all the time how many times you have watched a certain movie, what were the times where you paused it, what were the times when you rewinded it and rewatched certain parts, did you watch it to the very end, did you watch the credits with full volume and so on. And this information gives insight to them about your taste, because they know that you are interested in some kinds of parts of certain kinds of movies. And this way, they have a bigger view about your very own taste. Now, if you think about the immense success of House of Cards in the US, that wasn't an accident. They have information about the user base. They know that people really like to watch the works of David Fincher. And they also watched a lot of movies that had Kevin Spacey as an actor in it. And most of the viewers also were interested in British comedy and so on, and started to be active politically. So they realized why not put all this information together and create a series based on it, which was House of Cards, which was a great hit. Too bad they didn't have a machine learning algorithm to detect sexual predators, but that's another story. And the same goes for Spotify. Basically, whenever you listen to a song, then the more times you listen to certain kinds of song, the more information you will have about your users. And then later on, Spotify will search for users with similar taste and will provide you in the weekly discovery about songs that you have not yet listened to, but might be really similar to your taste. Which means, let us think it, that nowadays, one of the most strongest, most important assets for your company is actually your user base and user data. So every time your users generate information, you can make your machine learning algorithms even smarter and refine the experience they have. So the reason why Spotify is actually giving you free access for like half of the user base is not just because they need the revenue or they are so philanthropic that they want to give away their content for free. The reason they give it away for free is because whenever a free user is also listening to a song, they're also making information and they're also making Spotify better, which will drive in more people who are actually willing to pay for it. Same goes for most of the IT companies nowadays. If you think about Google, the reason they are giving away free hosting for your personal photos, now you can upload infinite amount of your photos to the cloud, is not because they are so interested and they want to give you a place where you can upload pictures about your grandmother. It's because they are also making their machine learning algorithm, their machine vision algorithms even smarter every time you're uploading a photo. Talking about machine vision, you might not have heard about the current advancements of neural networks. This is actually a neural network that was taught the image of Van Gogh's Starry Night. It has learned certain kinds of styles about the image and was forced to recreate the scene it sees on the left from the original Blade Runner in the style of Van Gogh. But this is not the only use case you can use it for, so artistic. For instance, if you teach it how meat looks like, you can also recreate presidential speeches, or if you're a vegan, you can use cauliflower. But these new kinds of technologies, neural networks, have a lot of potential, and they are being used in all kinds of fields. And for instance, this neural network was shown short clips with sound, and it has actually learned that certain kinds of actions in clips would create certain kinds of sounds. And afterwards, if you only showed them video clips, it would create the sounds a person would hear if one would hear this action. So if you would show it a kettle that is being hit with a drum, it would create a metallic hit sound. But it even goes further. For instance, the people have developed an algorithm where they can actually create fake speeches. The way this works is that by only using an audio of a talk, you can generate fake mouth movement and superimpose it on a static image. So they took an image, a static image of Obama, and they moved his mouth in a way the audio would represent it. And this way they could create a fake speech where Obama would actually say in a video what he only said in an audio. And right now, Adobe is also developing basically a Photoshop for sound, where you can include missing words, and also if you have about 20 minutes of audio from a certain person talking, you can create new words told by that person, even if they never said it. So if you combine these two, be prepared that many more fake news will be coming, where you can actually even fake presidential speeches that would feel really real. But there are some nice use cases for machine learning in audio as well. If you jazz improvisation created by machine learning, yeah, thank you. So it was actually talked a lot of jazz improvisations, and it has learned some kinds of context about it, and which note would follow another note probabilistically, and it is now creating jazz music on its own. Yeah, this is a neural network being taught with all the songs created by the Beatles. There's actually a little bit of cheating here, because the song is being rearranged and replayed by an actual orchestra, and lyrics were also written by a human, but the song itself was created by a neural network that was fed with all the songs of Beatles, and now it's dreaming up more songs from the Beatles on its own. Yeah, let's go for the last one. And if you think that this is something that's really out of this world and unreachable, this is actually a neural network taught on certain kinds of piano performances, and now once it's loaded, is playing piano on its own, basically infinitely. So if you want infinite piano background music for your coffee or something, you can have it with just by opening this browser. So thank you for your kind attention. That was mostly about my presentation, and I'm pretty sure that, as you can see, there are a lot of opportunities in both neural networks and all kinds of other machine learning techniques in the field of audio, and more of these solutions will appear and will be really common in everyday life. And I would also like to wish very good luck to all the lawyers out there, because soon enough you will have to face with problems like, for instance, if someone takes all the copyrighted songs, feeds it to a neural network, that neural network's code is being downloaded by someone else and run in the cloud, and someone creates a song of that, and someone creates a podcast about this song, and someone else takes that podcast and puts it into a YouTube video, and someone else puts a screenshot about the YouTube video and puts it in a blog post and reblogs it, then who the hell should go to jail for copyright infringement? Because it's like a chain of gray areas that is basically really apparent, because these are things that are really coming and you have to face it, because I have personally no idea how to solve this problem, but it, as you can see, it's certainly coming.